Good afternoon, everyone. Uh, my name is Roberto Sambi. Today, we're going to look at concrete material. Our subject, as we know, is building and structural construction and safety. We're going to focus on concrete material for slab and the beam. Uh, let's look at the introduction of our topic. Concrete is a composite construction material. Main components are as follows: cement, aggregate, water. And it is the concrete it is important in slab and beams to strengthen and rigidity and for durability. The composition of concrete. Cement. Cement is used to bind the material. Cement is used to bind the material. Water. Water is used to activate cement. Ensures the workability. It ensures the workability of the cement or of the mixture. Workability of the mixture. Fine aggregate. We have sand. Sand is the fine aggregate. It is smooth. It makes sure that our finish is smooth and it fills the void in the concrete. Coarse aggregate is gravel or stone. Adds bulk and strength. Admixture, it modifies properties like uh, seeing the workability of the concrete. Uh, let's look at concrete in slabs, how it works. Purpose, let's look at the purpose first. The purpose is to horizontal elements carrying floor load. It makes sure that the load carried by floor does not, the floor does not get cracked. Types, ground floor, suspended reinforced slab. And then we have we have things that we should take into consideration. Adequate compressive strength, use of reinforcement, steel bars or the mesh. And the last one is proper curing to prevent cracks. We must make sure that our concrete goes the process of curing so that we can avoid the cracks. Let's look at the concrete in beams, how it works. The purpose: horizontal members transferring the load to the column or wall. Remember, the beams is carried by the column, is supported by the column and the wall. So the beam transfers the load to the column and the wall. Function. Let's look at the function. It resists binding and shear forces. Concrete and reinforcement. High compressive strength at top and reinforcement at bottom for tension. Proper cover to prevent corrosion. Here is how we're going to apply. We're going to follow the step when we mix the design, when we mix our concrete ratio. Application, mix ratio, cement, sand, stone, forms concrete mixture. Light duty slabs. When you mix for light duty slabs, you're going to use 1 cement, 3 wheelbarrow of sand, and 6 wheelbarrow of stones for light duty slabs. The ratio is 1 is to 3 is to 6. You must make sure you follow the ratio for light duty slabs. And then for reinforced slabs or beams, it's going to be 1 is to 2 is to 4. In that case, it's going to be 1 cement, 2 wheelbarrow of sand, and then 4 wheelbarrow of stone. The ratio is for reinforced slabs and beams. For heavy duty structural concrete, it's going to be 1 is to 1, 1.5 is to 3. In that case, it's going to be 1 cement, 1.5 wheelbarrow of sand, and 3 wheelbarrow of stone for heavy duty structural concrete. For a proper mixture, proper mix ensures the strength and the durability and workability of the structure. It's either of the beam or of the slab. When I say a structure, I refer to a beam or a slab. Now let's go to next slide. Now let's look at the curing and maintenance of the concrete. For curing, you must keep the concrete moist for 7 days. In that case, 7 plus days. In that case, you must make sure within 7 days, every day you must go pour the water on top of the slab or on top of the concrete to keep the moist for curing so that it can cure properly. You must prevent rapid drying to avoid cracks. Rapid drying, it causes cracks if the sun is too light, if the sun is too hot for a day. You must avoid the concrete to be dry rapidly. You must pour the water often so that you're going to avoid the cracks on the concrete. Proper curing improves strength and durability. If your concrete goes a process of proper curing, that's where you're going to improve the strength and durability of the concrete. Let's look at the common defects. If you don't follow the proper curing, you're going to experience cracks, poor curing, and overload. Honeycomb beam, poor compaction. If you don't compact your concrete properly, you're going to experience honeycomb beam. And if you know you're not going to do, you're going to do a poor curing, you're going to experience cracks. And then the last one is improper mixing and or placement. If you're not going to mix your concrete properly, you're going to experience segregation. You're going to experience segregation. Make sure you do your proper mixing and proper placement. Next, let's look at the next slide. Here's our last slide. We're going to look at safety and quality control. First one, use PPE when working with concrete. You must make sure you wear proper PPE. First, you must wear work suit. You must wear gloves, proper gloves. You must wear a working mask. You must wear goggles. You must wear boots. And yeah, you must make sure you wear a proper PPE for your health and safety. And then the next one, the next one, you must uh, ensure stable and clean formwork. Make sure where you are going to mix your concrete, you first you clear your site. You must work on a well space. You must have enough space where you are working. And first you clear your site. The last one, you must conduct slump test or cube test for quality measures. Uh, After mixing your concrete, you do the slump test to test the concrete strength and durability. If the concrete does not meet the requirement test or measured, that's why you're gonna uh, start mixing again your concrete until you reach the correct measurement for the test. This is our last slide, guys. Today this for a day. So I thank you. If anyone has a question, and then you will ask. I'm available at any time. Thank you.